which are 11N or MIMO products. The first one is the ingenious 9752 indoor router access point, which has 2 transmitters and 2 receivers. And this product can be run in either B, BG, pure N, or mixed modes. Say, I'm not a big fan of the mixed mode because it seems to be the worst case of the 11N and the worst case of the G. But it will actually work in the mixed mode if you want. The other thing it can do is it allows you to select those coding schemes. Now, most people will probably want to set it on auto because I'm sure the product is a lot better able to working up the best coding scheme than probably the user. But you can, if you want, override this. You can see here it supports the obligatory 0 to 15 coding schemes. And also, you can decide whether you want it to use 20 meg wide channels or auto 2040. So the device itself will make a sensible choice as to which channel to use. And it's got this thing called CTS protection, and I'm really annoyed because I've forgotten what CTS protection is. I knew last week and I've forgotten now. I'll have to go look that up later on. Right, let's go to the next slide. Now, the previous product I'll show you was a fairly basic 11M piece of equipment. It did the bare necessary to be called an 11M piece of kit. The Finet WL1514N product is an outdoor 5 gig, important that 5 gig, that means it can actually do proper 11N work. It's an outdoor product which is sort of the next generation along. This actually has better support for some of the 11N principles. So, if I just look at the wireless setup for this device, you can see it has lots of stuff over here to enable you to actually play with the high throughput settings. So the first thing is, just like the previous product, you can actually decide whether you want it to run in pure 11A, of course 11A because this is 5 gig, or whether you want it to run in N mode or a mixed mode. So you can actually select which one you want to use. And this product actually uses the 5 gig unlicensed band B section. Probably seen my previous webinars on 5 gig. You know, the band B is the medium power middle band primarily for outdoor usage. Now, I also remember I said at the beginning that for the MIMO technology to work, what you need to do is essentially have multiple transmitters and multiple receivers. Now, the way this product gets around it is it's got 2 antennas actually built into the front. It's got 2 14 dB antennas. And what they've done is they've got one antenna which is pointing up, so the signal comes out up and down from the front of it, and they've orientated the other antenna through 90 degrees. So behind here is another separate antenna which is sending the signal horizontally. Now, this is quite a neat trick because what this does is it allows you to run the 2 streams or 2 transmitters in a very compact design. So that way they can actually have this very, very small product. It's literally on the size of a sort of large paperback book, but give you a good gain and still operate the multiple stream technology. As I say before, this is 2 transmitters and 2 receivers operating inside here. And you can actually, if you want, have it run in the pure 11N Greenfield mode. Remember, I've mentioned that about 2 slides back. Or a mixed mode, which is where it'll talk to 11N kit and 11G kit. Just like all 11N equipment, it supports the obligatory MCS 0 to 15 modes, but this product also supports the MCS 32. So it's gone a stage further. This is a product starting to support some of the other coding schemes. And the MCS 32 is where it sends duplicate packets, duplicate data streams out, but on 2 separate channels, 2 20 meg wide channels. That extra channel is called the extension channel, and here you can actually allow it to auto-select the extension channel or specify the extension channel. So what this will do is it'll still give you quite a reasonable throughput, but a much more reliable throughput. sure that wasn't supposed to happen. Oh, there we go. Okay, so let's look at these 11N characteristics in more detail. So the other thing that we can play around is the guard interval. Remember I said we've got a difference between a 400 nanosecond guard interval or an 800 nanosecond guard interval. Well, this product allows us to actually alter the guard interval. So this is something that wasn't available on the more basic indoor product. So this allows us to decide which guard interval to be used. I'm sure most people will just put it on auto and assume the device can actually choose the best setting for itself. Now, another thing this product can do, which the previous one can't do, is what is called reverse direction grant, or RDG. Now, RDG is linked into this thing called TXOP. I can't remember what TXOP means, but what it basically means is that when a transmitter is going to send data to receiver, the transmitter has an option of reserving a time slot big enough for it to send multiple frames of data. So the ability here is that it's grabbed that section of time. So if you've got a multiple device, multiple access point, multiple client network, then what happens is this device has grabbed that channel, that section of bandwidth for a certain period of time. And during that period of time, it doesn't have to worry that anybody else will be transmitting. Now that lack of having to worry about other devices transmitting means it can send the data much more efficiently. And the time that it's allowed to actually send the data is set by this parameter called the TXOP, or the TXOP time. I must admit, on this device you can't actually alter that. Maybe you will in the future, or maybe they thought that's too powerful a thing to give mere users the ability to play with. Because obviously you could actually cause real serious degradation performance on your network if you started to play around with that parameter and got it wrong. What you can do here is, if a transmitter has reserved a time slot, now what the transmitter can do is, although it's reserved a time slot, I don't know, let's give a figure. Let's say it's 100 nanoseconds. So it's reserved a 100 nanosecond time slot to send some data. If it only needs half of that, 50 nanoseconds, then in that same reserved time slot, it can allow the receiver to send data back. So these two devices are using the same spare reserved time slot, and this is called reverse direction grant. And in this product you can enable it or disable it. I don't know why you'd want to disable it, because it sounds a good thing to me, but you can if you want. The other thing it's got here is it's got that frame aggregation parameter I mentioned before. You can enable it or disable it. And this frame aggregation, MSDU, what it actually does is it aggregates the frames based upon quality of service or service type. So if you've got a bunch of frames which are all being used, for example, for voice over IP, what this function will do is it will actually aggregate the frames, all those voice over IP, into single frames, which is basically, it's a way of doing quality of service on the data stream. Now, going back, remember I said that you can use block acknowledgements with 11N. Well, this product just allows you to actually enable or disable block acknowledgements. And this function here, decline block acknowledgement, basically means that if it receives a message from the other end saying, I want to use block acknowledgements, then you can actually reply saying, yes, you can use them, or no, you can't use them. All this input is quite important because if you're trying to send a lot of data, for example, on an email, then the top priority is obviously just to send that data as fast as possible. But that's not so with, for example, applications like voice over IP. With voice over IP, it's very important that all the devices have an opportunity to reply. Otherwise, you end up with extremely one-sided speech, for example. Or worse, what will happen is the VoIP transmitter will go, oh, there's something wrong, I'm not getting a reply from back the other end, and disconnect the link. So controlling these parameters is very important when you're playing around with time-critical processes like voice over IP.